Michael. I'm a senior developer advocate at GitLab. And in today's GitLab Duo Coffee Chat, we also want to look into refactoring source code. And not just refactoring like C code, which you can see here, but actually refactoring it into Rust. This is today's challenge. And before we start or before we dive in, we need to familiarize ourselves with the source code. I've prepared an example for printing operating system version information. So this is something I used to develop many, many years ago. And typically every operating system behaves differently or provides different headers, includes SDKs, whatnot. So you really need to know what to do. The good thing here is I didn't write this myself just for now. I use GitLab Duo Code Suggestions. So this is code that is actually working. So it has been prepared for us. We can, for instance, or for example, say we navigate into the C directory and call make. Actually, I should have run make clean before. Now we run make again to prove we're actually compiling the source code. And you can see a new binary OS underscore info has been generated. And on my macOS, it prints the platform name and version information that gets extracted. If I would run that on Linux, I would get a different information similar to Windows. Now, this is a relatively simple example, but we also want to understand what the code is doing, what the code does. Can use Duo Chat here, select the source code, type in /explain in the prompt. So this is JetBrains CLion. So you can also write C code, not just C++, in CLion, and also use GitLab Duo Code Suggestions to generate code. Now, while we wait, no, we're not waiting. GitLab Duo Chat is super fast just now. It provides us with an overview of like what the code is doing for the different operating systems, and also explains that the code is using cross-platform programming techniques, using preprocessor directives like if-def, elif-else. So the code will be compiled depending on the platform. As you can see over here, this is like on Windows, Apple, and everything else is treated as Linux. We can say, please explain potential problems, like refining the prompt again to get a better understanding of like what could be a challenge of refactoring that or what might not be available. And it tries to actually fix that for us already. My next step would have been to ask what to use /refactor. But yeah, the Windows API deprecation, the code uses get version X, which has been deprecated, I think, for 8 years, 10 years now, but it's still available. Microsoft recommends version helper functions. But yeah, this is something we can, you probably have to deal with in the future if you want to stick with the C portions. Incomplete Windows information is a problem. There's a potential buffer overflow in the UTS name struct. Oh, interesting. And yes, so it's a good way to actually have security scanning and other things attached to that. But yes, we can refactor that, and we can see the magic if then else things with is Windows 10 or greater, is Windows 8 or greater, is Windows 7 or greater, which is an interesting way of finding this out on Windows. I have been doing this 10 years ago, so I know plenty of that. But the question is not like what we did 10 years. We actually want to refactor that. So the first step could be, say, refactor just nothing. Let's just figure out whether GitLab Duo Chat is capable of refactoring the C code again, which it already did before. But in this area, it could also provide us with like this time functions to store the information, to retrieve that, which is great. Make the code more testable. So assuming that we have refactored that into functions, we could actually use /tests to generate tests for that, and so on. So this is a great way to use GitLab Duo with C and refactoring that. But what could happen if we say we want to refactor that into Rust? Does it work? Hopefully. And again, it's super fast with streaming the responses. Just need to wait a bit because the source code is potentially a little longer than the IDE prompt here. But again, it's amazing how fast C and Rust generated code is here. The refactored version in Rust uses specific macros for Windows, and then it's like different versions. So this looks relatively, yeah, this looks okay actually. On if not any, okay, this is for Linux then, or like any other system that provides the uname helpers or the uname command to get the information. So I'm on macOS. I probably don't have uname here, but let's not overcomplicated. One thing we want to do is like use the Rust code here, copy that, and then navigate into prepared Rust project. So you can see I ran cargo init earlier, and I can also run cargo build, which it already did. Let's fake a little change here. And you can see code suggestions would actually kick in. So I installed a Rust plugin into CLion to have code suggestions available, which also works then if you want to complete the picture. But let's run the binary using cargo run. Hello GitLab Duo Code Challenge. Replace this code with the refactored C code from the os.c file. So this is like the instructions for the challenge here. Let's copy paste that in. And do we need to do anything else here? The Rust version accomplishes the same task with some key differences. It uses Rust conditional compilation features to handle platform-specific code. Okay. For Windows, it uses the winapi crate. Okay. How to add the winapi crate for Windows. Let's follow up on this. Okay. Yeah, I would love to learn a lot of things. Potentially the newest version of the winapi, which we need to check, but for now this is sufficient. So we copy that, open the cargo.toml, and then it's duplicated. So let's just keep that and use that. We cannot test it now, but we should prepare our code to be cross-compiled, being tested on different platforms, for example, in CI/CD. And what else is different? On macOS, it's using env-const, get operating system information. It uses the command structure to run uname commands. Okay, on Unix systems. Memory safety is improved by using Rust safe abstractions and avoiding raw pointers, except where necessary in the Windows-specific code. Okay. Where are raw pointers? Let's see. The Windows-specific code has... this is the unsafe block. Can you make the unsafe block safe here? I don't know if this works, but let's try it. Okay. Interesting. So we can actually continue refactoring or like improving the source code after it got refactored once from C to Rust. And here it says, okay, it still needs access to that. Here's a safer version. Okay, I'm not sure what's. It does some more error checking. Okay. Yeah, I think we can continue like that, but we cannot really test it. So what I'm curious now is like I want to test it again. So we're using cargo build again, and it cannot be compiled because happened. OS version is not defined. Okay. Env const. Did we include env consts? Explain why OS version is not found in env consts. Is in the code. Let's select the source code. Maybe I need to import a crate. Oh. And the rest area. So, it's not one of them. Oh, that's quite interesting. It not only explains it, it also provides a fix for the macOS section. Okay, let's use a fix for the macOS section. This was actually so I did play around with this before this video. I wanted to run sw underscore VERS as a command to get better version information on macOS. So if we use that, does it work? Yeah, it works because we're actually only building like this part. We need to test Linux and Windows on a separate platform. So I even get like, oh, this is actually better information than I was getting before with using an alternate approach. Now it tells me it's the platform is macOS and the version is 14.5, 14.5, yes, which is the latest macOS release. I think 14.6 is in beta right now. Will be coming out later this year. So this source code works, and the great thing is I haven't written a single line of source code here. The only thing we needed to do was after refactoring, ensuring that a specific constant is not defined, but we were able to actually test it. Now, when I run git status, the only thing we modified here was really the Rust code, obviously, and we have improved that. Now, the other thing is now to say refactor for add more error handling. Could also fix for performance, but error handling is typically a thing. Let's see. It's thinking, it's generating. There's a lot of things. The thing is, this refactoring step is not always necessary. So if it works for you, it's great. But it's also like a good challenge to figure out, hey, maybe we want to create a function, which it actually does here. So it uses a struct. It uses something, yeah, to actually print an error. And then again, it has to open the OS info and actually like captures that string from UTF-8. So we will actually see an error if that cannot be converted, which is great. So if a malicious thing happens or something gets passed, what shouldn't belong there will be treated elsewhere. Let's see if this works. For now, I think we should check out a new branch, like solution 1, and commit first solution refactored for Mac OS, and then test specific solution and see whether this works. As always, I don't trust anyone giving me code. I want to run and build it, especially now. Okay, we have the same result. I think we can potentially break it by I probably shouldn't rename the software version command, but I could create my own binary and kind of inject that into testing, which produces strange output, and then kind of break the source code in production. But this goes beyond what I wanted to try today. So now we have improved error handling. And you can see we'll immediately push that we have the branch pushed to the repository or the project on gitlab.com, which is great. To summarize what we did just now or did today in the session is we have analyzed or tried to understand the C program for printing operating system in a cross-platform way. We've asked GitLab Duo Chat what could be improved in the C code. We even asked it to refactor the C code, but then went into the challenge of refactoring the C code into Rust. The first version that was refactored didn't work because there was a constant on macOS which was not available. And we also have seen that on Windows, certain unsafe API calls need to be made. We asked Duo Chat whether we can remove the unsafe calls, but it's not possible. But it also provided us with a more safe approach with more error handling. Moving on, we fixed the problems with the environment and constants, and also asked Duo Chat to refactor that into a better version, which uses the SW_verse, which is software version in an abbreviated way on macOS, and we're able to get a more error prone or better functionality or a more readable code, but also a more safe code, and also more maintainable. So it uses specific Rust features to ensure the code is maintainable. And the result is here. It's pushed into specific solution 1 Git branch in the challenge repository. So you can just figure that, check it out, make it work, but also do the challenge as you like. I will link all the resources in the video description, and we will continue our GitLab Duo learning journey in our coffee chats with more refactoring, fix, explanation, anything that comes to mind as a developer task, or like improving the developer experience with a little help from AI. See you next time.